Let's vote. Off. Wow, okay. So Chris, here's an example of a poll. The margin of error would be irrelevant. Close to 80%, 90%. Even a sample size as small as this one, I'm guessing the margin would be about 20, 21%, somewhere in that neighborhood. It'd be so large we wouldn't have to worry about it. There, here's your quiz solution for you. If this were a scientific poll.
You didn't ask for how many people were going to vote.
That's true, but most of you voted yes, so I don't have to worry about them too much because they're close to zero.
Most of us voted.
Just need pillows and blankets and a cup of hot cocoa and boom, a little fire crackling up the front. I think we have all the classrooms have a fireplace.
One of them little electric ones.
That's what I'm saying. Right, the president.
Fire.
Shirley Metcalf's awesome. Our new president. Have you met Shirley yet, our new president, our interim president? About this tall, Hawaiian, totally red. Totally red. I keep trying to give it to her to stay. Shirley, if you're watching this, please stay. Yeah, she'd be good for the school. Anyway, how much does one of these things weigh? We didn't get very far. I mean, well, we did. I shouldn't say we didn't get very far. We didn't answer the question.
On average, over half a pound.
Okay, so we have a vote for on average over half a pound. So what Chris is doing, thank you, sir.
You're not getting ripped off.
Hang on now. I would say exactly the opposite, actually, depending on what you define as ripped off. This is what we kind of walked through yesterday. We were developing a correlation between the estimation of a percentage and the estimation of an average. Because that's the whole point, is we want to be able to do both things. We want to be able to estimate both kinds of parameters using sample statistics. So this was how we've gotten pretty comfortable estimating proportions over here. I want to make sure we're comfortable estimating averages over here. So it's all about the margin of error, as Chris has pointed out today. Thank you, sir. It's all about the margin, the correct margin to put onto a test statistic. You guys had X bar figured out immediately yesterday. I mean, as soon as I gave you those, 30 numbers, you were like, boom, had it, done, finished. So if I remember correctly, and I don't, so I'm going to recalculate it real quick. And you don't have to. I saved it. I was smart enough. I almost hit clear in 243 yesterday. I'm like, oh no, copy it over to L6 so you don't lose it. So I have, check me on this if you have your numbers in front of you. I'm in 243, we're good. Or 244. I have an average of 0.526 pounds with a standard deviation of 0.025 pounds. Thank you. Now that, and we have a sample size of 30, we should probably put that down too. Because that's going to change things. The larger your sample, as Chris taught us 2 weeks ago, the larger your sample, shorter your margin of error. So you got to know how many. That's why when I did that little unscientific poll moments ago, I said it's going to have a wide margin, only 30 people in here. And you're saying to yourself, wait a minute, there's 30 here too. How's that going to change? And it's all about this formula. It really is. There's so much about these formulas that is so interesting to analyze mathematically. I try not to too much because I feel that you guys don't really care for the mathematics that much. If you ever do, of course, that's where I put the enrichment page stuff. It's all buried in there for you if you want to watch it or read it. So I think we can do this. I think we can do this. We can form our margin of error by simply dividing that standard deviation by the square root of n. Why the square root of n? Why? Square root of n. Magical, square root of n. It's a square root of n over here too. What the hell, square root of n, square root of n. Give me 3 words that say why it should be there. Rhymes with ventral squamate theorem. Yes! The central limit theorem, which you've all forgotten, which is totally fine. As I told you in 243, you're going to forget this. Because it's one of those things you don't use on a daily basis, but you interpret on a daily basis if you're paying attention to statistics. Because this guy right here has to be there whenever you're estimating. You're going to be amazed at how many root n's you see in this class, and they're all based on that central limit theorem. It's this wonderful little piece of glue that holds 243 to 244. Awesome. So that is your sample's standard deviation. When you do that, it becomes what's called a standard error, which you probably have forgotten too. You've probably forgotten that too. That's like little s for an inferential sampling distribution. Okay? Perfect. So let's go over to this sideboard and just crunch through it once. We still cool with the lights off? I should write bigger.